13.2, slope of a line. When we talk about slope, we're talking about measuring the steepness of a line. Okay, and this line, remember, represents all the solutions to a linear equation. Okay, the steepness of a line can be described as saying the rise over the run, or the change in the y direction over the change in the x direction. Okay, so it's just slope. M is the letter we use. And that is just describing the steepness, and this is how we calculate it. Change in y over the change in x. Okay, so if we want to do a couple of examples to really learn this, let's look at this right here. So we know we need to do, for slope, again, change in y divided by change in x, which we call it rise over run. So you take your 2 points. We have point -3, -1. That's our first point right here. Take your second point, which is right here, which is 3, 4. So to find the change in y, take your second point, 4, subtract your first point, -1. We get a 5. And then we got to calculate our change in x, which we end up at 3. We started out at -3, so that equals 6. So our m slope is 5, 6, 5 over 6, meaning we're going to rise 5, 1, 2, 3, 4, 5, and go over run 6. Rise, run, rise, run. And so that could describe this whole line right here. This is positive slope, meaning your line looks like that. Okay, for the other one, again, change in y over change in x. And our first point is this one here, -1, 1. Our second point is here, which is 1, -2. So to find our change in y, we take our second point, -2, subtract our first point, 1. That becomes a -3. And our change in x is, we end up at 1, but we started out at -1. A 1 plus a 1 minus a -1 is 1 plus 1, which equals 2. So our m for this line, our slope, is -3/2. That means we're going to go down 3 over 2, down 3 over 2, right? It's important to note that this one has a negative slope, and the line actually looks like this. Okay? Positive, negative. Now, when we want to find the slope of a horizontal line, for instance, this one here, we don't care what x value it is. We do care, though, that the y value must always be what? 5. Okay? So for this one, on the other ones, remember, this was considered a positive slope and this one was considered a negative slope. Well, this one here, a slope that looks like this, that's considered a 0 slope. Okay? Now on this one here, this is a vertical line. Our vertical line, we don't care what y value we have, but we do care that we must always have an x value of 4. Okay? Remember, it looks like this. So for this one, our line looks like this. We have a positive slope, negative slope, a 0 slope. This one is actually called undefined slope, because we would end up with our change in y over change in x. Well, what's our change in y? Well, our change in y here is 2. Our change in y here is 4. And our change in x, our x doesn't change, does it? It's a 0. But remember, you can't ever divide by 0. You can't have 0 as a denominator. And so this one is considered undefined. All right, so here's a quick summary of the slopes. Remember, this one's a positive slope. This one's a negative slope. And so your m here is going to be positive. Your m here is going to be negative. Your m here is going to be a y equals some number. And this one is an x equals some number, right? So positive slope, negative slope, zero slope, undefined slope. All right, time for you to write in your notes. You can add the definition of slope, give the description of slope, meaning what are the 4 different types we can have, and then label the graphs that show the different types of slopes. Okay, the other thing we can do when we can calculate slope is it can help us determine if lines are parallel. So in order for lines to be parallel, they have to have the same slope, right? This one here has a slope of 1/2. You go up 1/2, up 1/2. This one also has a slope of 1/2, up 1/2, up 1/2. So these 2 lines are parallel. Now, if you looked at these, you would find that one of them is not parallel to the others. Okay, this blue one has a slope of 4. This red one has a slope of 5. And this green one has also a slope of 4. Meaning, remember, you take your change in y over change in x between these 2 points on the line, and that's going to give you your m, your slope. So the blue line and the green line are parallel. All right, time for you to quickly write in your notes describing what graphs of parallel lines have in common. And now time to do 3 practice problems. Okay, the first practice problem, you are just going to find the slope. Remember, change in y over change in x. So you take your 2 points. Here's your first point. Here's your second point. So you do your b minus your a, right? So for instance, I will do the change in y for you. So our y value, we end up at 2, but we started at 3. So our change in y is actually a -1. We're going down 1, right? So now you can calculate your change in x, and then that's going to give you your slope. Okay, looking at practice problems 2 and 3. These ones, you don't even need to look at the graph. You just need to merely look at the 2 points that are given to you. They're saying that the slope, that a line passes through these 2 points, and we want to calculate the slope or the steepness of that line. So again, change in y over change in x, or your rise over your run. Here's your where you ended up. Here's where you started. Here's where you ended up, and here's where you started. So for this first one, our slope is going to be -2 plus 2 over 6. What is that? And how would you describe that slope? Okay, so on number 3, the same thing, change in y over change in x, right? Here's your second point, here's your first point, where you started or ended up minus where you started. That equals a -2. But what about your x, change in x, and what's that going to be? And that's going to tell you what your slope is. Okay, and that is it for 13.2.